Hello everyone. Good morning, good evening, good afternoon from wherever you watch. Today we shall be discussing Gauss law on an imaginary Gaussian surface. And our chosen surface is a cylinder, and presenting this will be Ashley, Aranya, and Washington.
So, who is Friedrich Gauss?
German mathematician and physicist, born in April 1777. Carl Friedrich Gauss made many discoveries in mathematics and physics, such as the number theory, geometry, electromagnetism, and the Gauss law.
Our points of discussion will be the Gauss's law and its relationship to the electric flux.
What is electric flux? It is the measure of the electric field through a given surface. If there is no charge in the enclosed object, therefore there is no electric field in the surface and ultimately no flux. Total flux is the amount of the flux in an initially small area, no a surface, which we will talk about later, are adding together. There is an exact charge within the enclosed object. The amount of electric flux that moves through the surface will be directly proportional to the amount of charge within the object. If there is a charge on the outside of the object, the electric field from the charge will not contribute to the flux to the object.
One of the components used to calculate Gauss' law is the net flux, and the net flux is defined as the amount of flux in an infinitely small area on a Gaussian surface which are added together. Net flux through a surface is proportional to the number of lines leaving the surface minus the number entering the surface.
Friedrich Gauss had a great contribution towards understanding the relationship between flux and charge. He came up with Gauss' law, which states that the flux of the electric field through an enclosed surface is equal to the enclosed net charge divided by the permittivity of free space. However, it is important to note that when the angle between the charge and the electric field is 90 degrees, we have a net flux of 0.
Now, moving on to our actual problem, the Gaussian surface. What is a Gaussian surface? It is an enclosed surface through which the flux of a vector is calculated. It also helps evaluate the electric field intensity due to a symmetric charge distribution. A Gaussian surface has to fulfill two conditions, which are it should be an enclosed surface and point of electric field calculation must pass through a closed surface. The electric field line must pass through it, and the electric field strength at any point on the surface must be the same and equal. A long wire that is positively charged forms a long uniform line of charge to calculate the electric field. We'll use the application of Gauss's law for our imaginary Gaussian surface. The direction of our field is symmetric on all dimensions. With the symmetry, we expect the field to be directed radially outwards because of the positive charge. Our perpendicular distance is marked as r. The cylindrical surface is closed on both ends, and the two surfaces are denoted as S1 and S2. The third surface has a length, and it is marked S3. Since our field is directed radially outward, there is no field for our first and second surface. And we need to remember that along a curved surface, net flux is 0 because theta is 90 degrees and cos of 90 is 0. Now, looking at Gauss's equation, we will need to calculate the area of the curved surface as well as the integral of the three different surfaces. We can take the first integral on Gauss's equation and break it down into the three integrals for each surface, where integral 1 and integral 2 are equals to 0, because E magnetic field, which is perpendicular to dA, is equals to 0. Why? Because the angle between them is 90 degrees, which cos theta of 90 is equals to 0. Now looking at our third integral, E times dA can be written as E is equals to 2 times pi times r times L, which is equals to the right side, which is equals to Q enclosed divided by epsilon naught. Q enclosed can be written as lambda times L, and that L will cancel the L on the left hand side. Then we'll remain with E is equals to 1 over 2 times pi epsilon naught, which is equals to lambda divided by r.